Hello there, and welcome to the Sleepy Science Stories. Somewhere on this planet, entire mountain ranges lie hidden beneath the blanket of ice, silent, colossal, untouched by human hands. Rivers flow beneath glaciers where no human has ever walked. Mysterious lakes, dark and frozen for millions of years, hide secrets of life itself. And yet these frozen giants are not lifeless. They breathe, they move, slowly, with a patience that spans millennia. Tonight, you are invited to step into a world where time moves differently, where the heartbeat of the earth is measured not in seconds, but in centuries. Imagine standing on a ridge high above a glacier. The wind cuts across the ice like a sharp blade. Snowflakes drift silently, each one a tiny, delicate crystal. They fall, land, and melt into the story of the mountain. Look closer. See the deep blue of the ice formed over centuries. Every shade tells a story. Every bubble trapped inside holds a whisper from a world long before us. A world of ice, dust, wind, life itself preserved. Glaciers are the archivists of our planet. They record the climate of Earth, the air we breathe, the ash from ancient volcanic eruptions, pollen from forests that existed thousands of years ago, even whispers of life that once thrived in places now frozen in time. Tonight, we do not rush. We will walk slowly among these giants, listen to their stories, and feel the pulse of ice beneath our feet. Each glacier has a heart, a place where snow gathers, layer upon layer, building, compressing, until it transforms into dense ice, strong enough to carve mountains. And each glacier has a foot, where ice meets the world beyond, melting, calving, pouring fresh water into rivers, oceans, and the lives of those who depend on it. Imagine the power it takes to shape entire valleys, to sculpt mountains, to move rocks the size of houses, all in silence, at a pace invisible to the human eye. Glaciers are artists, architects, archivists, and at times even storytellers. They leave marks on Earth that endure long after they are gone. U-shaped valleys, polished rocks, moraines, drumlins, evidence of a force both patient and immense. And yet, these giants are fragile. Their ice melts with rising temperatures, retreating like a slow sigh. They warn us of a warming world. They remind us of the delicate balance between life, water, and climate. Tonight, we will journey beneath the surface. Beneath the glimmering white ice lies a hidden world. Mountains buried for millions of years. Lakes isolated from the world. Rivers flowing silently, carving tunnels deep below. Life survives here too. Microbes and algae thrive in extreme cold. Tiny communities forming in cryoconite holes, adapted to darkness and pressure that would crush anything larger. And if we dare, we will hear the voices of the glaciers themselves, their groans, their cracks, their creaks, the haunting song of ice moving over rock, a symphony of forces, invisible yet immense. Glaciers have seen civilizations rise and fall, mountains grow and erode, oceans swell and recede, and yet they endure, a silent witness to Earth's ancient history and perhaps a mirror for our future. As you listen tonight, Feel the cold, not as discomfort, but as clarity. The ice slows everything down, forces us to breathe, to reflect, to observe. We will travel to the highest peaks where the first snowflakes fall. The birth of a glacier begins, and follow it as it flows, inch by inch, year by year, shaping the world in ways almost impossible to imagine. We will peer beneath the ice, into hidden lakes, into rivers of meltwater that move silently, powering glaciers from below, driving their slow, inexorable motion. We will watch as ice cracks, forming crevices hundreds of feet deep, as glaciers surge forward, unstoppable, as ice calves into the ocean with thunderous force. We will explore the colors of ice, deep blues, crystalline whites, occasional greens and reds, a living palette painted by time, pressure, and life. We will witness the interplay of ice and fire, subglacial volcanoes erupting, melting ice from below, creating sudden floods, reshaping valleys. A reminder that Earth is alive, dynamic, unpredictable. We will follow the pulse of water, the rivers that feed life downstream, the glaciers that store fresh water for millions, and the consequences when that ice retreats. We will hear the acoustic symphony of ice, groans, creaks, booms. The glacier's heartbeat was audible, a sound that reminds us of the scale, the force, and the fragility of these frozen giants. We will learn about life in extreme cold, microbes, algae, and extremophiles thriving in isolation, teaching us resilience, adaptation, and survival. We will explore the human story, the explorers who risked their lives, the cultures who revered ice as sacred, and the scientists who now uncover its secrets, revealing lessons for all humanity. And finally, we will confront the reality of a warming world, the retreat of glaciers, rising seas, and the call for understanding, preservation, and hope. Tonight, we invite you to let the ice speak, to slow your mind, to expand your imagination, to wander among giants, because in these frozen landscapes, we find both the story of Earth's past and the reflection of our shared future. Take a deep breath, listen to the silence, and let us begin the journey into the world of ice.
Our story does not begin with catastrophe, but with a whisper. A single snowflake descends onto a high mountain peak, then another and another. In the thin, cold air, these flakes do not melt. They accumulate, layer upon layer, forming a soft, porous substance called neve, or fern. This is the infancy of a glacier. Season after season, year after year, snow continues to gather. The weight of new snow compresses the older layers beneath. The delicate six-armed snowflakes collapse under pressure, air pockets squeezed out, until what was soft and fragile becomes granular ice, dense, strong, and alive with trapped ancient air. Yet this is only the beginning. For a glacier to truly exist, the ice must begin to move. When the ice grows thick enough, the pressure at its base overcomes its own internal strength. The crystals deform, sliding slowly past one another like honey left on a cold winter day. The static field of ice transforms into a river of frozen motion, alive with purpose, though moving only inches each day. It is now an agent of change, a sculptor of mountains, a recorder of time, an entity that will outlast civilizations. Every glacier has a heart, the accumulation zone, where snow gathers, compacts, and transforms into ice. And every glacier has a foot, its terminus, where ice melts, calves into the sea, or retreats. When accumulation exceeds melting, the glacier slowly advances, like a tide of ice sweeping through the valley. When melting dominates, it retreats, revealing landscapes it has carved over centuries. Glaciers are not static monuments. They are living, breathing systems, constantly being born and constantly dying in a slow, majestic dance spanning millennia. To understand a glacier, one must first understand snow. Each flake is unique, six-armed, crystalline. Light dances through its facets, reflecting the cold clarity of the high mountains. As snow accumulates, layers of history form, each layer recording the climate, the air, and the world of its time. Dust from faraway deserts, ash from volcanoes, microscopic pollen from distant forests, all trapped, preserved, waiting for someone to read the story. Over decades, the fern is pressed into ice. Tiny bubbles of ancient air locked inside, chemical signatures captured forever, a frozen record of Earth's atmosphere. Then the ice begins to move, slowly, almost imperceptibly, deforming under its own weight. The upper layers remain brittle, and as the glacier flows over uneven terrain, it cracks. These cracks are crevasses, deep, often hidden fissures plunging hundreds of feet into ice. Some are narrow, some wide enough to swallow a house, all a reminder of the immense forces at work. Glaciers also surge. Most glaciers move steadily, inch by inch, but some, surge-type glaciers, accelerate dramatically, moving tens or hundreds times faster for months or years, bulldozing everything in their path. These surges are unpredictable, a sudden display of the raw, hidden power of ice. And yet glaciers sometimes defy intuition. Ice can flow uphill, pushed by immense pressure from the thick ice behind, moving over ridges and hills like toothpaste being squeezed through a tube. The surface may slope downwards, but the base slowly climbs. This movement, this patient, unstoppable flow, is a symphony of physics, pressure, temperature, gravity, friction, all playing together on a scale that dwarfs human understanding. As we follow this glacier, we are witnessing a process that began long before humans and will continue long after. It teaches patience, resilience, and a deep respect for forces far larger than ourselves. Let us pause here to imagine the snowflakes landing on the mountain. The ice is slowly forming. The glacier is beginning to flow, a silent giant waking, inch by inch, shaping the world around it.
If the surface of a glacier is its skin, then beneath lies its skeleton, its circulatory system, a hidden kingdom of ice, pressure, and silence. Beneath the smooth, white expanse of glaciers in Greenland, Antarctica, entire mountain ranges lie buried, mountains as tall as the Alps, yet they have not seen sunlight for millions of years. The ice flows over their peaks and valleys, smoothing jagged edges, creating a hidden topography, guiding the movement of ice from below. A subtle swell on the surface may hint at a peak, but thousands of feet of ice conceal the true scale of the landscape beneath. We are only beginning to understand this secret world. Beneath the ice also lie lakes, subglacial lakes, dark and untouched. The most famous, Lake Vostok in Antarctica, a body of water the size of Lake Ontario, sealed under 2 miles of ice, isolated for perhaps 15 million years. Pressure from the overlying ice, combined with geothermal heat, keeps the water liquid, dark, and enigmatic. Scientists speculate that this pristine environment could harbor unique microbial life, organisms unseen anywhere else on Earth, an analog for icy moons like Europa or Enceladus. To probe these waters is to look back in time to a primordial Earth, or outward to the possibility of life beyond our planet. Rivers flow here too, but unlike the ones we see above ground, these subglacial rivers carve tunnels through ice or flow silently between ice and bedrock. Some carry volumes rivaling great rivers of the surface. They are the glacier's hidden plumbing, its secret engine pushing the ice forward. When water pressure builds beneath the glacier, it can lift the ice slightly, reducing friction, allowing the glacier to surge forward, sometimes with dramatic speed. This hidden world exists under extreme pressure, perpetual darkness, profound isolation. It is as alien as the deep ocean, as mysterious as the surface of another planet. Life, if it exists here, is adapted to extremes, resilient, tiny, and ancient. And yet, even in this darkness, the glacier moves. It flows over hidden peaks, through deep valleys, driven by the same forces as the surface ice: pressure, gravity, and the subtle lubrication of meltwater. Explorers and scientists have only recently begun to glimpse this kingdom. Radar and seismic surveys reveal a world we never knew existed, a world shaping the ice above it and the continents themselves. Imagine standing on the surface, completely unaware, while beneath your feet, mountains, rivers, and lakes stretch for miles. A hidden landscape, frozen in time, yet alive with movement and energy. These subglacial realms remind us how little we truly know of our planet. Above us, the glacier sparkles, white, serene, timeless. Beneath, a complex, dynamic system, a hidden kingdom, full of mystery and potential. As we explore further, we realize glaciers are not simply frozen water. They are entire ecosystems, engineering marvels, archives of life and history stretching across thousands of years. And the more we discover, the more questions arise. What organisms survive here, adapted to cold, darkness, and immense pressure? How do rivers flow beneath miles of ice, shaping the glacier's motion in ways we are only beginning to understand? What stories lie trapped in the layers of ice above and in the water below? In this hidden kingdom, the rules of our familiar world do not always apply. Time slows, motion is imperceptible, yet profound change is constant. Here, ice is alive. Pressure and water carve, lift, and shift, shaping continents silently, invisibly. Every crevasse, every hidden lake, Every subglacial river is part of the glacier's intricate, secret life. And tonight, as we journey deeper, we will witness the glacier's hidden heartbeat, its secret rivers, buried mountains, and timeless lakes, reminding us that the world beneath our feet is as vast, mysterious, and alive as the world above.
If the surface of a glacier is its skin, then beneath lies its skeleton, its circulatory system, a hidden kingdom of ice, pressure, and silence. Beneath the smooth, white expanse of glaciers in Greenland, Antarctica, entire mountain ranges lie buried. Mountains as tall as the Alps, yet they have not seen sunlight for millions of years. The ice flows over their peaks and valleys, smoothing jagged edges, creating a hidden topography, guiding the movement of ice from below. A subtle swell on the surface may hint at a peak, but thousands of feet of ice conceal the true scale of the landscape beneath. We are only beginning to understand this secret world. Beneath the ice also lie lakes, subglacial lakes, dark and untouched. The most famous, Lake Vostok in Antarctica, a body of water the size of Lake Ontario, sealed under 2 miles of ice, isolated for perhaps 15 million years. Pressure from the overlying ice, combined with geothermal heat, keeps the water liquid, dark, and enigmatic. Scientists speculate that this pristine environment could harbor unique microbial life, organisms unseen anywhere else on Earth, an analog for icy moons like Europa or Enceladus. To probe these waters is to look back in time to a primordial Earth, or outward to the possibility of life beyond our planet. Rivers flow here too, but unlike the ones we see above ground, these subglacial rivers carve tunnels through ice or flow silently between ice and bedrock. Some carry volumes rivaling great rivers of the surface. They are the glacier's hidden plumbing, its secret engine pushing the ice forward. When water pressure builds beneath the glacier, it can lift the ice slightly, reducing friction, allowing the glacier to surge forward, sometimes with dramatic speed. This hidden world exists under extreme pressure, perpetual darkness, profound isolation. It is as alien as the deep ocean, as mysterious as the surface of another planet. Life, if it exists here, is adapted to extremes, resilient, tiny, and ancient. And yet, even in this darkness, the glacier moves. It flows over hidden peaks, through deep valleys, driven by the same forces as the surface ice, pressure, gravity, and the subtle lubrication of meltwater. Explorers and scientists have only recently begun to glimpse this kingdom. Radar and seismic surveys reveal a world we never knew existed, a world shaping the ice above it and the continents themselves. Imagine standing on the surface, completely unaware, while beneath your feet, mountains, rivers, and lakes stretch for miles. A hidden landscape, frozen in time, yet alive with movement and energy. These subglacial realms remind us how little we truly know of our planet. Above us, the glacier sparkles, white, serene, timeless. Beneath it, a complex, dynamic system,
a hidden kingdom full of mystery and potential. As we explore further, we realize glaciers are not simply frozen water. They are entire ecosystems, engineering marvels, archives of life and history stretching across thousands of years. And the more we discover, the more questions rise. What organisms survive here, adapted to cold, darkness, and immense pressure? How do rivers flow beneath miles of ice, shaping the glacier's motion in ways we are only beginning to understand? What stories lie trapped in the layers of ice above and in the water below? In this hidden kingdom, the rules of our familiar world do not always apply. Time slows, motion is imperceptible, yet profound change is constant. Here, ice is alive. Pressure and water carve, lift, and shift, shaping continents silently, invisibly. Every crevasse, every hidden lake, every subglacial river is part of the glacier's intricate, secret life. And tonight, as we journey deeper, we will witness the glacier's hidden heartbeat, its secret rivers, buried mountains, and timeless lakes, reminding us that the world beneath our feet is as vast, mysterious, and alive as the world above.
To watch a glacier is to watch a portrait that slowly changes, a canvas in motion, painted over centuries. Its movement is almost imperceptible, yet relentless and powerful. It speaks a language of pressure, temperature, and gravity, of slow deformation and sudden fracture. There are two primary ways a glacier moves. The first is internal deformation. Imagine a stack of books left on a shelf for a century. Slowly, the pages at the bottom compress and bend, yielding to the weight above. Deep within the glacier, the ice crystals behave in the same way. Under pressures hundreds of times greater than our atmosphere, they stretch, recrystallize, and flow, causing the entire mass of ice to move like a slow, viscous fluid. The second is basal sliding. Here, meltwater lubricates the base of the glacier, allowing it to slide over the bedrock beneath. On warm summer days, surface meltwater funnels down crevices and moulines, reaching the base and causing the glacier to literally glide over its frozen foundation. But glacier movement is not always smooth. As ice flows over uneven terrain, the upper layers cannot deform plastically enough. They crack. These cracks are crevices. Some are narrow enough to step over, others wide enough to swallow a building. Some are hidden beneath a fragile snow bridge, deadly traps for the unwary. Then there are surges. Most glaciers move at a steady, predictable pace, but surge-type glaciers experience episodes of rapid acceleration. For months or even years, a glacier may lurch forward, tens or hundreds of times faster than usual, bulldozing everything in its path. The triggers for surges are still not fully understood, but scientists suspect changes in subglacial water pressure or the buildup of internal ice stress. A surging glacier is a reminder of the immense, often hidden power lying dormant beneath the surface. Sometimes, glaciers even defy intuition. Under the right conditions, ice can flow uphill. Gravity drives the motion, but the pressure from thick ice behind can push ice over ridges and hills, like toothpaste squeezed through a tube. The surface may slope downwards, but the base moves up, slowly yet inexorably, reshaping valleys in ways that seem impossible. Every crevice, every fracture, every surge is a word in the glacier's language, a language spoken over centuries, inches per day, silent yet powerful, revealing the forces that shape our planet. Watching a glacier move is like reading a novel. Each crack, each bend, each surge, a chapter written in ice. It teaches patience, a lesson in the slow, powerful, persistent processes of nature, unlike anything we experience in our fast-paced human world. Some glaciers flow over deep valleys. Others tumble over cliffs, forming ice falls, where the ice fractures dramatically, plunging into deep crevices with thunderous force. The ice fractures, stretches, and occasionally surges, yet continues its slow, unstoppable journey, sculpting the land, carving valleys, and shaping mountains. In observing this motion, we begin to understand the glacier's dual nature. It is patient, yet powerful. It is quiet, yet capable of dramatic, sudden change. It is alive in ways subtle and profound. From high above, glaciers appear calm, a frozen river of white and blue. But below the surface, and within its body, the glacier speaks, in deformation, in fractures, in the hidden surge of movement, revealing the symphony of forces that govern our world. Understanding the language of glaciers is to understand the slow but unstoppable forces of nature, the patient power of ice, and the profound beauty of a world moving in slow motion over centuries, millennia, and beyond. As we continue, we will begin to read history in the ice itself, to explore the frozen archive where climate, life, and time are preserved, layer by layer, century by century.
If we could choose a single library to understand the story of our planet, it would be the glaciers. These rivers of ice are unparalleled archives, preserving a continuous, year-by-year record of Earth's climate, atmosphere, and history. The process is simple, yet extraordinary. Each winter, a new layer of snow falls. Within its delicate crystals, it captures the atmosphere of its time, the air we breathe, the dust from distant deserts, ash from volcanic eruptions, even pollen drifting from forests far away. All are preserved, frozen in time. When summer comes, a new layer of snow covers the old, protecting it, preserving it, year after year, millennium after millennium, building a vertical timeline, a living record of our planet's past. By drilling deep into ice sheets in Greenland and Antarctica, scientists extract ice cores, cylindrical samples spanning thousands of years, even hundreds of thousands of years. Reading an ice core is like reading a book. One layer per page, each bubble of trapped air a word, telling the story of greenhouse gases, temperature, and climate cycles. From these frozen pages, we learn of ice ages and warm interglacials, and the dramatic rise of carbon dioxide since the Industrial Revolution. Dust layers reveal ancient droughts, volcanic ash pinpoint eruptions that cooled the planet, and isotopes of oxygen act as a thermometer, telling us the precise temperature when each snowflake fell. One of the most profound discoveries comes from the Vostok ice core in Antarctica. This record stretches back 800,000 years, showing an undeniable correlation between temperature and greenhouse gas levels. A fundamental lesson delivered from the depths of ice about the mechanics of our climate system. But glaciers preserve more than chemical data. They preserve life itself. In high mountains, retreating glaciers reveal the stumps of ancient forests, trees once overrun by ice thousands of years ago. In the Arctic, melting ice unveils the bodies of prehistoric animals, woolly mammoths, perfectly preserved, their skin, hair, even stomach contents intact. Frozen mummies offering an intimate glimpse into ancient ecosystems. The ice is a meticulous recorder, silent, patient, yet precise. It holds the evidence of Earth's past and provides context for understanding the present and perhaps the future. Every layer is a page, every bubble a letter, every core a chapter, telling the story of Earth through snow, ice, and time. Imagine the precision a snowflake falls in 1000 BCE, trapped, preserved, and today, scientists read it, understanding the air, the climate, and the life of that era. Glaciers are time capsules, preserving information not only about our environment, but also about the resilience of life, its adaptation, its fragility. Every ice core drilled, every layer examined, reveals the delicate balance of nature and how humans have altered it in mere centuries. And there is more. Glaciers contain chemical signatures of ancient oceans, revealing the rise and fall of sea levels. They tell stories of volcanic eruptions, ancient fires, and even cosmic events like meteors depositing tiny particles in ice layers. Reading ice is like reading a biography of the Earth itself, written slowly, meticulously, over tens of thousands of years, a narrative we are only beginning to comprehend. The frozen archive also teaches us humility. In the face of these glaciers, human history seems brief, fleeting, almost insignificant, a single paragraph in a book spanning millennia. And yet, our actions today leave marks, tiny, almost invisible, but enough to alter the next chapters. These archives are not just scientific tools, they are storytellers, silent witnesses to Earth's triumphs and struggles, reminding us of the delicate dance of climate, life, and time. As we journey further, we will see how glaciers have sculpted the landscape, from valleys and cirques to mountains and fjords, leaving footprints of ice across continents, evidence of their patient, unstoppable force.
Glaciers are not merely rivers of ice, they are master sculptors of the Earth. Over millennia, they carve valleys, shape mountains, and leave indelible marks on the landscape. Their tools are simple: ice, pressure, and the relentless force of gravity. The most recognizable feature shaped by glaciers is the U-shaped valley. Unlike the V-shaped valleys carved by rivers, these broad, deep troughs are smooth and symmetrical. As a glacier flows down a mountain, it scours the valley floor and rounds the walls, leaving a signature U-shape, a testament to its slow, patient strength. At the heads of these valleys, glaciers carve cirques, bowl-shaped depressions that often cradle small glacial lakes. Cirques are the cradles of glaciers, where snow accumulates, compacts, and transforms into ice, forming the birthplace of rivers of frozen water. Between cirques, ridges called arêtes form sharp, knife-edged divides created as glaciers erode parallel valleys. Where several cirques meet, a horn emerges, a pointed mountain peak, jagged and majestic like the Matterhorn in the Swiss Alps, standing as a monument to the glacier's patient work. Glaciers also leave behind smoother features. As ice moves over bedrock, it polishes the surface and sometimes leaves striations, long grooves carved by rocks and debris embedded in the ice. These striations are evidence of the glacier's movement, etched into stone, a permanent record of its slow passage. Moraines are another signature of glacial work. Ridges of debris carried and deposited by ice form lateral moraines along the sides, terminal moraines marking the furthest advance, and medial moraines tracing the paths where glaciers merge, all telling a story of the glacier's journey across the land. Beyond moraines, glaciers create fjords, steep-walled coastal valleys filled by the sea. Where ice once dominated, water now flows, a dramatic testament to the glacier's sculpting power. Other subtle marks remain: drumlins, eskers, and kettles, shapes molded by ice, pressure, and meltwater. Erratics, large boulders transported vast distances by ice, stand as silent witnesses to a journey over centuries, even millennia. Every curve, ridge, and polished rock is a word in the glacier's language, a message written slowly and deliberately over timescales far beyond human comprehension. To walk among these landscapes is to read a story written in stone and ice, a narrative of persistence, pressure, and time. The U-shaped valleys speak of flowing ice, the horns tell of countless centuries of erosion, and the striated rocks whisper of the glacier's patient movement. Even the smallest features, a polished stone or a tiny striation, hold information about the glacier's past, the speed of its flow, the pressure it exerted, and the path it took. Glaciers are both artists and archivists. They sculpt the land with deliberate patience, yet preserve a record of their own existence, etched into rock, sediment, and valley alike. When we observe the landscapes they have shaped, we gain insight not only into the power of ice, but into the forces that shape our planet, the slow, unstoppable processes of nature that operate on a scale beyond our daily perception. In these valleys and peaks, in polished rocks and jagged ridges, we see the fingerprint of glaciers, an enduring testament to their artistry, patience, and silent, unstoppable force. Glaciers are more than rivers of ice. They are canvases painted in subtle hues, a palette shaped by physics, light, and life. When you first look at a glacier, you may see only white, a vast, blinding expanse stretching to the horizon. But on closer observation, you notice shades of blue, gray, and even black, each telling a story about the ice, its structure, and its history. The brilliant blue of a glacier comes from the very nature of ice itself. Ice absorbs longer wavelengths of light, like red and yellow, and scatters the shorter wavelengths, primarily blue. The denser the ice, the more intense the blue,
revealing layers compressed over centuries as trapped air bubbles are slowly squeezed out, creating pure crystalline ice. Black ice tells another story. It appears dark and almost opaque, a window into the glacier's depths. This ice contains very few air bubbles, allowing light to pass through deeply and giving the surface a glassy, almost liquid appearance, a mirror of the surrounding sky and mountains. Glaciers also carry dust, volcanic ash, and sediment, tiny particles that darken the ice. Cryoconite, a combination of dust, soot, and microbes, can accumulate in small holes on the glacier's surface, creating black dots that absorb heat and speed localized melting, a subtle interaction between color and life. There is also color from life itself. Algal blooms sometimes flourish on glacier surfaces, painting the ice in shades of green, red, or orange. These microbes survive in extreme conditions, and in doing so turn the glacier into a living, breathing canvas, a testament to resilience in one of Earth's harshest environments. Light interacts with ice in magical ways. When the sun is low, shadows stretch across crevices, revealing depth and texture. Sunlight-penetrating ice can create an ethereal glow, casting a soft blue luminescence from within, as if the glacier itself is breathing light. Reflections, refractions, and scattering all play a role in the glacier's visual symphony. A single icefall can display every shade, from sparkling white to deep, intense blue, with hints of black where rocks and debris are embedded. These colors are not just beautiful, they are indicators. Blue ice tells us about compression and age. Black ice reveals purity and density. And red or green algae highlight the presence of life. Every hue is a clue, a signal from the glacier itself. To understand glaciers, we must see them not just as frozen rivers, but as dynamic landscapes of light and color, living canvases shaped by time, pressure, and biology. Observing the palette of ice teaches patience, attention, and appreciation for subtlety, for the smallest shifts in hue can tell a story centuries in the making. From the brilliant blues of dense ice to the dark mirrors of black ice, to the living reds and greens of algal blooms, the glacier communicates its history, composition, and vitality, all through the language of color and light. When we walk among these colors, we are not just witnessing beauty. We are reading a story written over millennia, layer by layer, shade by shade, an intimate portrait of Earth's frozen masterpieces.
Glaciers are not merely rivers of ice, they are master sculptors of the earth. Over millennia, they carve valleys, shape mountains, and leave indelible marks on the landscape. Their tools are simple: ice, pressure, and the relentless force of gravity. The most recognizable feature shaped by glaciers is the U-shaped valley. Unlike the V-shaped valleys carved by rivers, these broad, deep troughs are smooth and symmetrical. As a glacier flows down a mountain, it scours the valley floor and rounds the walls, leaving a signature U-shape, a testament to its slow, patient strength. At the heads of these valleys, glaciers carve cirques, bowl-shaped depressions that often cradle small glacial lakes. Cirques are the cradles of glaciers, where snow accumulates, compacts, and transforms into ice, forming the birthplace of rivers of frozen water. Between cirques, ridges called arêtes form sharp, knife-edged divides created as glaciers erode parallel valleys. Where several cirques meet, a horn emerges, a pointed mountain peak, jagged and majestic like the Matterhorn in the Swiss Alps, standing as a monument to the glacier's patient work. Glaciers also leave behind smoother features. As ice moves over bedrock, it polishes the surface and sometimes leaves striations, long grooves carved by rocks and debris embedded in the ice. These striations are evidence of the glacier's movement, etched into stone, a permanent record of its slow passage. Moraines are another signature of glacial work. Ridges of debris carried and deposited by ice form lateral moraines along the sides, terminal moraines marking the furthest advance, and medial moraines tracing the paths where glaciers merge, all telling a story of the glacier's journey across the land. Beyond moraines, glaciers create fjords, steep-walled coastal valleys filled by the sea. Where ice once dominated, water now flows, a dramatic testament to the glacier's sculpting power. Other subtle marks remain: drumlins, eskers, and kettles, shapes molded by ice, pressure, and meltwater. Erratics, large boulders transported vast distances by ice, stand as silent witnesses to a journey over centuries, even millennia. Every curve, ridge, and polished rock is a word in the glacier's language, a message written slowly and deliberately over timescales far beyond human comprehension. To walk among these landscapes is to read a story written in stone and ice, a narrative of persistence, pressure, and time. The U-shaped valleys speak of flowing ice. The horns tell of countless centuries of erosion, and the striated rocks whisper of the glacier's patient movement. Even the smallest features, a polished stone or a tiny striation, hold information about the glacier's past, the speed of its flow, the pressure it exerted, and the path it took. Glaciers are both artists and archivists. They sculpt the land with deliberate patience, yet preserve a record of their own existence, etched into rock, sediment, and valley alike. When we observe the landscapes they have shaped, we gain insight not only into the power of ice, but into the forces that shape our planet, the slow, unstoppable processes of nature that operate on a scale beyond our daily perception. In these valleys and peaks, in polished rocks and jagged ridges, we see the fingerprint of glaciers, an enduring testament to their artistry, patience, and silent, unstoppable force. Glaciers are more than rivers of ice. They are canvases painted in subtle hues, a palette shaped by physics, light, and life. When you first look at a glacier, you may see only white, a vast, blinding expanse stretching to the horizon. But on closer observation, you notice shades of blue, gray, and even black, each telling a story about the ice, its structure, and its history. The brilliant blue of a glacier comes from the very nature of ice itself. Ice absorbs longer wavelengths of light, like red and yellow, and scatters the shorter wavelengths, primarily blue. The denser the ice, the more intense the blue, revealing layers compressed over centuries as trapped air bubbles are slowly squeezed out, creating pure crystalline ice. Black ice tells another story. It appears dark and almost opaque, a window into the glacier's depths. This ice contains very few air bubbles, allowing light to pass through deeply and giving the surface a glassy, almost liquid appearance, a mirror of the surrounding sky and mountains. Glaciers also carry dust, volcanic ash, and sediment, tiny particles that darken the ice. Cryoconite, a combination of dust, soot, and microbes, can accumulate in small holes on the glacier's surface, creating black dots that absorb heat and speed localized melting, a subtle interaction between color and life.
There is also color from life itself. Algal blooms sometimes flourish on glacier surfaces, painting the ice in shades of green, red, or orange. These microbes survive in extreme conditions, and in doing so turn the glacier into a living, breathing canvas, a testament to resilience in one of Earth's harshest environments. Light interacts with ice in magical ways. When the sun is low, shadows stretch across crevices, revealing depth and texture. Sunlight-penetrating ice can create an ethereal glow, casting a soft blue luminescence from within, as if the glacier itself is breathing light. Reflections, refractions, and scattering all play a role in the glacier's visual symphony. A single icefall can display every shade, from sparkling white to deep, intense blue, with hints of black where rocks and debris are embedded. These colors are not just beautiful, they are indicators. Blue ice tells us about compression and age. Black ice reveals purity and density. And red or green algae highlight the presence of life. Every hue is a clue, a signal from the glacier itself. To understand glaciers, we must see them not just as frozen rivers, but as dynamic landscapes of light and color, living canvases shaped by time, pressure, and biology. Observing the palette of ice teaches patience, attention, and appreciation for subtlety, for the smallest shifts in hue can tell a story centuries in the making. From the brilliant blues of dense ice to the dark mirrors of black ice, to the living reds and greens of algal blooms, the glacier communicates its history, composition, and vitality, all through the language of color and light. When we walk among these colors, we are not just witnessing beauty, we are reading a story written over millennia, layer by layer, shade by shade, an intimate portrait of Earth's frozen masterpieces.
Where glaciers meet the sea, a unique world emerges. It is the boundary between ice and water, between slow, ancient rivers and the restless ocean. Tidewater glaciers are the most dramatic of these interfaces. These glaciers extend from mountains to fjords, terminating in the ocean. Here, the ice does not simply melt quietly. It calves, massive chunks of ice breaking away, plunging into the sea with tremendous force. Calving is both beautiful and violent. The ice, compressed over centuries, shatters into jagged blocks, creating icebergs that drift into the ocean, some the size of skyscrapers, some small enough to float past unnoticed. Each one is a fragment of the glacier's history, its weight, its age, its journey preserved in frozen form. Ice shelves are another marvel. These floating extensions of continental glaciers, often hundreds of feet thick, act as barriers, slowing the flow of ice into the ocean. Their stability is vital. When ice shelves collapse, glaciers behind them accelerate, pouring ice into the sea and contributing to rising sea levels. The ocean itself interacts with glaciers in complex ways. Warmer water beneath ice shelves melts them from below, while surface temperatures and winds influence calving and retreat. This delicate interface, where ice and ocean meet, is a dynamic, living boundary, constantly reshaped by forces seen and unseen. Submerged ice is a hidden world. Beneath the surface, glaciers extend further than the eye can see, with underwater faces sculpted by meltwater, currents, and pressure. These submerged portions support unique ecosystems, from cold water plankton to tiny fish feeding larger predators, a hidden food web sustained by the glacier's presence.
As glaciers retreat into the ocean, they carry sediment and nutrients, fertilizing marine environments and creating new habitats for life. Yet there is a cost. Rapid glacier retreat contributes to rising seas, affecting coastal communities, ecosystems, and weather patterns worldwide. The interface between ice and ocean is a mirror of the planet's changing climate, a delicate balance under threat. Understanding this boundary is crucial. Scientists use satellites, sonar, and ice-penetrating radar to track calving events, ice thickness, and movement. They study how ocean currents and temperatures influence glaciers and how glaciers, in turn, shape the oceans. It is a dance of forces, a slow, powerful, interconnected system where ice and water meet in perpetual negotiation. The icy interface teaches us about interdependence. Ice shapes the oceans, and oceans shape the ice. This dialogue has continued for millennia, and it is changing faster than ever before as our planet warms and human impact accelerates these processes. To stand at the edge of a tidewater glacier, to watch the calving, to feel the ocean spray on your face, is to witness the raw, intimate connection between ice and water, between past and present, and between stability and change. From fjords and ice shelves to calving icebergs and hidden underwater faces, the interface between glaciers and the ocean is a frontier, one of beauty and power and fragility, a place where we can read the pulse of the planet and the consequences of our changing climate. Glaciers are not silent. Though their movement is slow and deliberate, they speak in a language of sound, a language that tells stories of pressure, fracture, and flow. When we listen closely, we hear the glacier's heartbeat. Groans, creaks, and deep resonant booms echo across valleys, each one a message, a signal of forces at work, forces invisible to the eye. There are high-pitched chirps and pops, small fractures forming in the brittle ice. These are the glacier's whispers, telling of stress points and slow deformation, subtle shifts that will eventually shape the landscape. Then there are the deep, resonant groans, the low hum of hundreds of feet of ice slowly moving and deforming internally, rearranging its structure under immense pressure. These sounds can travel for miles, a symphony of ice, telling the story of its journey over centuries. During calving events, the glacier speaks in thunder. Massive blocks of ice breaking away, plunging into water with a roar, splashing and reverberating, reminding us of the immense energy stored in this frozen river. Glaciers also sing. When ice bends under stress, fractures slightly, then snaps, it produces harmonic tones, sometimes referred to as the singing of ice. These sounds are subtle, musical, and haunting, an acoustic fingerprint of glacial movement. Even subglacial rivers contribute to this symphony. Meltwater rushing beneath kilometers of ice, carving channels and tunnels, creates gurgling, flowing, and rushing sounds, echoing through the hidden underworld of the glacier. The acoustic world of glaciers teaches us to listen, to interpret the signs, and to understand the dynamics of slow, powerful systems, not just through sight, but through sound. Scientists use specialized microphones called geophones to record these sounds. From them, they can infer ice thickness, movement, stress points, and even predict calving events or surges. The glacier communicates, and we are beginning to understand its language. Listening to a glacier is like listening to time itself, for centuries compressed into sound waves, a melody of patience, force, and transformation. From the whispers of small crevasses to the groans of massive ice flows to the thunder of calving, the glacier speaks in multiple registers, each sound a clue to its inner workings, each note a testament to its immense power. As we tune our ears to these frozen symphonies, we learn humility. we realize that glaciers, though slow, deliberate, and patient, possess power that can reshape mountains, valleys, and even coastlines. The acoustic world of glaciers is not just a natural curiosity. It is a tool, a teacher, and a storyteller, allowing us to hear the pulse of ice, and through it, the pulse of our planet.
At first glance, glaciers appear lifeless, vast expanses of white and blue, harsh, cold, and inhospitable. Yet life persists even in these frozen deserts. Extremophiles, organisms that thrive in extreme conditions, have adapted to survive in ice, snow, and subglacial lakes. Microbes, bacteria, algae, and even tiny multicellular creatures live where humans would perish within minutes. Cryoconite is one such marvel. It is a mixture of dust, soot, and microbial life, collected in small holes on the glacier surface. Here, algae flourish, feeding on nutrients carried by wind, and in doing so, they create tiny ecosystems alive with microscopic activity. Beneath the ice, subglacial lakes host life in total darkness. Lake Vostok, isolated for over 15 million years, contains microbial life that survives in extreme cold and high pressure, fed only by nutrients trapped under kilometers of ice. Studying these organisms offers insight into the limits of life on Earth and hints at the possibility of life elsewhere in our solar system, on icy moons like Europa and Enceladus. The ice itself can host life. Algae, bacteria, and fungi colonize snow and ice surfaces, sometimes creating colorful blooms, red, green, or orange. These organisms influence melting, absorbing sunlight, warming the surface slightly, and creating feedback loops that affect glacier dynamics. Even in these extreme environments, interconnected food webs exist. Microbes feed on nutrients trapped in ice, small invertebrates graze on microbial mats, and larger organisms, like insects or birds, exploit these pockets of productivity, creating ecosystems invisible to the casual observer, yet teeming with life in miniature. Life in ice teaches resilience. These extremophiles endure freezing temperatures, limited nutrients, high radiation, and centuries of darkness. They are living proof that life adapts, even in the most unforgiving conditions on Earth. Studying these ecosystems, scientists uncover clues about early Earth, when life first emerged in harsh climates, and about the resilience of life under changing environmental conditions. Glacier ecosystems are fragile. As glaciers retreat due to warming, these specialized habitats face disruption, and species may be lost before we even discover them. They are sentinels of climate change, reminding us of the delicate balance between life and environment and the consequences of rapid change. From cryoconite holes to subglacial lakes, from microbial mats to tiny invertebrates, life persists, adapts, and thrives, even on ice that seems empty and dead. It is a testament to the resilience of nature and to the intricate, hidden connections that sustain ecosystems in places most of us will never see. Life on glaciers is a quiet, hidden drama, unfolding over centuries in conditions that challenge the very definition of survival. And yet it persists, thrives, and whispers the story of adaptation, endurance, and resilience. Glaciers are more than frozen rivers. They are the pulse of fresh water on our planet. They store water over centuries and release it slowly, sustaining rivers, ecosystems, and human communities downstream. In mountain regions, glacial melt feeds rivers during dry seasons, providing water for drinking, irrigation, and hydropower.
Communities depend on this slow release, often unaware of the centuries of accumulation behind each drop. Glaciers act as natural reservoirs. Snowfall accumulates, compresses into ice, and gradually melts, feeding streams and rivers, smoothing seasonal fluctuations, and maintaining balance in the water cycle. As glaciers retreat, this balance is disrupted. Rivers that once flowed steadily now experience surges and shortages, impacting agriculture, hydroelectric power, and drinking water supply, demonstrating the profound importance of these frozen reservoirs. Glaciers also influence groundwater. Meltwater seeps into aquifers, recharging underground reserves that communities rely on, connecting glaciers to ecosystems far from the ice itself. Even slight changes in melt patterns can ripple across entire watersheds, affecting both human and ecological systems. Beyond immediate human use, glacial meltwaters shape landscapes. They transport sediment, form lakes, rivers, and deltas, and create fertile plains downstream. A legacy of ice shaping life far beyond its frozen confines. Seasonal pulses of meltwater also influence marine ecosystems. Nutrient-rich freshwater flows into fjords and coastal waters, supporting plankton blooms, which sustain fish, birds, and larger predators. A cascading effect from ice to ocean. The pulse of water from glaciers is both lifeline and warning. It reminds us that water is not just a resource, but a legacy of time, accumulated over centuries of snow and ice. As climate warms, this pulse quickens. Ice melts faster, and water flows too rapidly, then disappears, leaving landscapes, ecosystems, and communities vulnerable. Understanding glaciers as freshwater reservoirs is essential for sustainable water management. From high mountain valleys to the farthest rivers, glaciers dictate water availability and connect us all to the frozen past. Every glacier is a reservoir, every meltwater stream a lifeline, and every retreating ice front a reminder that the pulse of water is fragile and intimately tied to our planet's climate and our own survival. To witness a glacier's melt is to see time, patience, and water converging, a rhythm as old as the mountains and as vital as life itself.
As glaciers advance and retreat, they leave behind footprints, not of flesh and bone, but of rock, sediment, and sculpted landscapes. These footprints are the legacy of ice, evidence of its immense power and patient persistence. Moraines, drumlins, eskers, kettles, and erratics all speak of a glacier's journey across the land. Moraines are ridges of debris pushed and deposited at the glacier's edges, telltale signs of its advance, sometimes forming natural dams, creating lakes behind them, a record of ice's slow march over centuries. Drumlins are streamlined hills formed beneath moving ice, oriented in the direction of ice flow, like arrows pointing to the glacier's past movement, a signature written in stone and soil. Eskers are winding ridges of gravel and sand, deposited by subglacial rivers, threading across the landscape like frozen veins, telling of hidden flows beneath the ice, a secret world now revealed as the glacier retreats. Kettles are depressions left behind, where ice blocks were buried in sediment, then melted, forming lakes or ponds. Tiny memorials of a glacier's passing, echoes of a frozen past in liquid form. Erratics are solitary boulders, transported hundreds of miles by ice, plopped down in landscapes where they seem out of place. Their presence is a reminder of the glacier's immense strength, its ability to move mountains, or at least rocks of unimaginable size. All these landforms together paint a picture of glaciers as sculptors, slow, patient, yet relentless. They carve valleys, polish bedrock, and shape entire mountain ranges.
their fingerprints etched across the continents. U-shaped valleys are among the most iconic glacial sculptures, formed as ice erodes and widens river valleys, creating smooth, steep-sided troughs, a contrast to the V-shaped valleys carved by rivers alone. Cirques are bowl-shaped depressions carved at the heads of glaciers, often hosting small lakes called tarns, perfectly illustrating ice's ability to mold landscapes delicately, yet with immense power. Arêtes and horns are sharp, dramatic features created where multiple glaciers erode a mountain from different sides, leaving jagged ridges and pointed peaks. Nature's sculpture by ice and time. Glacial polish and striations reveal the intimate contact between ice and rock. Smooth, shiny surfaces and grooves carved by embedded rocks testify to the grinding, scraping, and sculpting, a silent record of ice's patient labor over millennia. Each landform, from moraine to erratic, from drumlin to cirque, is a story written by ice, a testimony to its presence, movement, and interaction with the earth. By reading these footprints, we can reconstruct the glacier's past, understand its dynamics, and predict its influence on future landscapes. For ice is both artist and historian, sculpting land and recording time in stone and sediment. To walk among these glacial landforms is to walk in the footsteps of giants, and to witness the slow, deliberate artistry of ice itself. Glaciers and volcanoes are two forces that seem opposed, one cold, patient, and frozen, the other fiery, volatile, and eruptive. Yet they interact in extraordinary ways, creating landscapes of striking contrasts where fire and ice coexist and sometimes clash with dramatic consequences. Subglacial volcanoes, hidden beneath ice sheets, are among the most mysterious of these interactions. Magma rises beneath kilometers of ice, heating it, melting it, and creating massive lakes of meltwater, sometimes triggering sudden floods called Jokulhlaups. A Jokulhlaup is a glacial outburst flood, an event of immense power and unpredictability. Water trapped beneath the ice builds pressure until the ice dam gives way, releasing torrents of water, rocks, and sediment downstream, reshaping valleys in hours that ice would normally carve in centuries. Volcanic eruptions beneath ice also create unique landforms. When lava meets ice, explosive interactions can occur, forming pillow lava, tuff cones, and ice marginal ridges. These formations are records of fire meeting ice, capturing moments of violent but ephemeral equilibrium. Iceland is a prime example, where glaciers sit atop active volcanoes, and eruptions under ice have shaped the land for millennia. The interplay of meltwater, magma, and ice creates lakes, floods, and new terrain, a living laboratory of Earth's dynamic forces. These processes also affect the ocean. Sudden glacial outbursts carry sediment and nutrients into fjords and coastal waters, impacting marine life, feeding plankton blooms, and altering the chemistry of the water temporarily. Volcanoes beneath ice are also important for understanding climate history. Layers of volcanic ash trapped in ice sheets provide time markers, helping scientists date glacial events and reconstruct past climates, revealing the interconnectedness of Earth's systems. The contrast between fire and ice is a reminder that Earth's forces are often intertwined, opposing yet complementary, destructive yet creative, sculpting landscapes that are breathtaking in their scale and complexity. Studying the volcanic connection beneath glaciers helps us predict hazards, understand glacial dynamics, and glimpse the power of our planet, all while appreciating the delicate balance between the frozen patience of ice and the fiery intensity of magma. In this intersection of fire and ice, we see Earth in motion, its forces slow and fast, patient and sudden, and we are reminded that even in the frozen world, heat, pressure, and energy leave their mark, forever recorded in stone, ice, and water.
Glaciers have long captured human imagination, not merely as ice and stone, but as symbols of time, endurance, and mystery. Throughout history, they inspired myths and legends, from the frost giants of Norse mythology to the sacred ice mountains of Tibet and the Andes. People saw glaciers as living entities, powerful, eternal, and often dangerous, worthy of awe and respect. Early explorers ventured into glacial realms, often at great personal risk. In the 19th and early 20th centuries, adventurers like Fridtjof Nansen and Ernest Shackleton crossed ice sheets and climbed peaks, pushing the boundaries of human endurance and chronicling the frozen world in journals, sketches, and photographs. Glaciers also influenced culture in more subtle ways. They shaped valleys and landscapes where civilizations settled, provided water and resources, and even influenced art, literature, and music, capturing the imagination of poets, painters, and composers who sought to express the majesty and mystery of ice. In modern times, glaciers continue to inspire, drawing scientists, photographers, and travelers to witness their beauty and understand their complexity. Mountaineers tackle ice falls and crevasses, researchers drill ice cores, and tourists marvel at calving icebergs and glacial lakes, all seeking connection to these ancient giants. But glaciers have also been teachers. They reveal human impact on the environment. Their retreat is a stark visual indicator of climate change, a warning etched in ice and stone, showing that our actions leave a mark on the planet. Art and storytelling continue to reflect glaciers' influence, from literature that romanticizes the frozen frontier to films capturing icy wildernesses and photographs that immortalize glacial light and shadow. Humans remain captivated by the frozen world. Indigenous peoples often view glaciers as sacred, sources of water, spirit, and life, teaching reverence for natural cycles and respect for the land. Their stories remind us that glaciers are not just objects of study, but integral parts of human history, culture, and survival. Exploration of glaciers has also led to scientific breakthroughs. Mapping ice sheets, drilling cores, and studying glacier dynamics has expanded our understanding of climate, geology, and hydrology. In every expedition, from perilous climbs to methodical research, humans engage directly with the frozen archives of Earth's history. The human story with glaciers is one of awe, respect, and curiosity, of challenge and inspiration, of danger and discovery, and of learning to listen to a language older than civilizations, spoken in ice, stone, and meltwater. To engage with glaciers is to engage with time itself, to witness forces that move slowly yet inexorably, and to understand humanity's place in a larger, frozen narrative where patience, endurance, and observation reveal lessons about life, nature, and the passage of centuries.
As we reach the final chapter of our journey, we turn our gaze forward to the future of ice and the hope carried by those who study it. Glaciers are no longer just distant wonders. They are vital indicators of our planet's health. Their retreat and behavior tell us stories of climate, water, and ecosystems, challenging us to understand and act. Scientists across the globe are engaged in meticulous research, from drilling ice cores thousands of meters deep to using satellites to track ice mass and movement, to deploying sensors that measure temperature, pressure, and meltwater flow. Each piece of data adds to the mosaic of understanding. These efforts reveal not only past climates locked in ice for hundreds of thousands of years, but also the trajectories of future change and the urgent need for mitigation. Yet, amidst the concern, there is hope. Innovative approaches in conservation, sustainable water management, and climate adaptation offer pathways to protect communities and ecosystems dependent on glacial melt. Remote glaciers, once unreachable, are now connected to us through technology.
Drones, satellites, and AI allow constant monitoring, giving scientists real-time insights and enabling early warnings of floods, ice surges, and environmental change. But the story of future ice is not only about science. It is about human responsibility, how our choices, energy use, and stewardship of the planet can influence whether glaciers continue their slow, patient existence or vanish within a lifetime. Glaciers remind us of timescales beyond our own. They teach patience, resilience, and humility, and they inspire innovation and hope as scientists, policymakers, and communities work together to protect these frozen sentinels. The future ice is also a symbol of interconnection. The water that flows from glaciers sustains life, agriculture, and ecosystems far from their frozen peaks, linking humans, animals, and plants in a fragile, delicate web. In our understanding and preservation of glaciers, we discover lessons for living about balance, foresight, and respect for natural systems. And we are reminded that even the largest forces require care, observation, and thoughtful action. As we conclude this journey, let us carry with us the stillness of ice, its patient flow, its immense power, and its fragile beauty. Let us honor the legacy it holds and embrace the responsibility to ensure its survival for the generations to come. The frozen world is not lost. It is alive, teaching, warning, and inspiring. The future ice is a story still being written by nature, by science, and by us. Good night. As we reach the final chapter of our journey, we turn our gaze forward to the future of ice and the hope carried by those who study it. Glaciers are no longer just distant wonders. They are vital indicators of our planet's health. Their retreat and behavior tell us stories of climate, water, and ecosystems, challenging us to understand and act. Scientists across the globe are engaged in meticulous research, from drilling ice cores thousands of meters deep, to using satellites to track ice mass and movement, to deploying sensors that measure temperature, pressure, and meltwater flow. Each piece of data adds to the mosaic of understanding. These efforts reveal not only past climates locked in ice for hundreds of thousands of years, but also the trajectories of future change and the urgent need for mitigation. Yet, amidst the concern, there is hope. Innovative approaches in conservation, sustainable water management, and climate adaptation offer pathways to protect communities and ecosystems dependent on glacial melt. Remote glaciers, once unreachable, are now connected to us through technology. Drones, satellites, and AI allow constant monitoring, giving scientists real-time insights and enabling early warnings of floods, ice surges, and environmental change. But the story of future ice is not only about science. It is about human responsibility, how our choices, energy use, and stewardship of the planet can influence whether glaciers continue their slow, patient existence or vanish within a lifetime. Glaciers remind us of timescales beyond our own. They teach patience, resilience, and humility, and they inspire innovation and hope as scientists, policymakers, and communities work together to protect these frozen sentinels. The future ice is also a symbol of interconnection. The water that flows from glaciers sustains life, agriculture, and ecosystems far from their frozen peaks, linking humans, animals, and plants in a fragile, delicate web. In our understanding and preservation of glaciers, we discover lessons for living about balance, foresight, and respect for natural systems. And we are reminded that even the largest forces require care, observation, and thoughtful action. As we conclude this journey, let us carry with us the stillness of ice, its patient flow, its immense power, and its fragile beauty. Let us honor the legacy it holds and embrace the responsibility to ensure its survival for the generations to come. The frozen world is not lost. It is alive, teaching, warning, and inspiring. The future ice is a story still being written by nature, by science, and by us. Good night.